Hi, everyone. I'm Shayna here from DataKine and really excited to be joining you all today and to be a part of Open Data Week. For those that aren't familiar with DataKine, we're a global nonprofit that's focused on using data science and AI for positive social impact. And what that means practically is that we build tools and products for social impact organizations to help those organizations use data to make better, more confident decisions for the communities that they serve. And we do work across portfolios that address economic opportunity, humanitarian action, climate, environment, education, and more. And so success for us at DataKine is really when those solutions that are created are adopted widely and contribute positively to that impact. So my colleagues and I are going to be sharing some of these products with you today. First off, we're going to start with previewing with you all our US Communities platform tool. For some of you that are familiar, it's currently listed as Ladder, but we will be going through a name change soon, which is pretty exciting. And so today I'm going to talk through the challenges that we heard from our community partners that really helped to create the opportunity from which this platform was developed. We'll discuss its evolution. I'll share with you a demo of the platform as well as a couple of use cases specific to New York using the open data. Okay, so most organizations that I've had the pleasure of speaking with within respective communities shared with us that in many cases they have a lot of data, whether it's from public open source data, city agencies, maybe their own programmatic data, maybe even partner databases that they would have to request. And so, what we heard a lot from our partners was that the problem wasn't necessarily not enough data. We live in a time where perhaps we have the most access to it. It was more about the data not talking to one another and that having its impact in terms of not having a clear so what. So you can see in this image here in the center of the screen, there were challenges expressed around disconnected data sets coming in from a variety of different directions. And then being able to have limited insights as a result of that, maybe uncertainty in what those insights mean and how that can actually lead to potentially missed opportunities. And so, what that meant for a lot of organizations, even, was spending a lot of time cleaning and merging files just to answer a basic question, for example, around identifying communities in need of services. And so, from DataKind's perspective, I'd like to share with you all in hearing those needs. We started out by building standalone tools and individual products for specific sectors like economic opportunity, housing, food security, etc. And each tool was useful on its own, but we also heard from our users and organizations that this is helpful, but it shows only one part of the picture as it relates to our communities. So we asked ourselves, what would it take to unlock more value for those organizations and hearing that feedback? And where we landed on was integrating our products into a platform, bringing those tools and functionalities together where organizations could see multiple dimensions of community needs, as you can see here in these examples: economic health, housing, transportation, demographics, etc. And at the same time, we heard from communities that they weren't just asking for this data in one view, but they also wanted to inquire about ways to facilitate working together in a team format, whether it was within an organization or even across organizations or sectors. And so here's where we landed with the platform. So, what is it exactly? At its core, it's a free data analysis and mapping tool that turns complex public and uploaded data into place based insights to share and collaborate through a teaming function. And it's designed for the social impact sector, as well as including practitioners as a user. We wanted to recognize, and we built with the intention of recognizing that this is a platform that's not just exclusive to data team members, it's inclusive of those members as well as other practitioners that are doing community based work. And so I want to take you through some of those feature and benefits that were developed as a result of the feedback of challenges that we heard from our partner organizations in the development of the platform. So, first, as you can see in this first row, again, we heard a lot around community members not having a single view of community need across sectors. So, we brought in 50 public indicators from across the economic, health, housing, transportation, as well as demographics to help facilitate seeing the full picture of local needs. There was also a need around one's organization's programmatic data living in a spreadsheet that's disconnected from that public data, therefore also disconnected in terms of seeing the full community context. That's where we implemented the data upload feature, which allows an organization to bring their data into the platform to see both that information as well as public information in a single view. We also heard from organizations that they may have interest in bringing that public data and taking it into their own internal systems for analysis. And so we included a data set builder that allows for spending less time cleaning data, it's standardized, and it's downloadable. And as I alluded to before, we also heard from organizations a need to break down silos, whether it was within an organization or across different organizations or sectors. So we have a team account, which again helps facilitate breaking down those silos and building an evidence based picture of community. We have three access levels. There's a team owner that's able to create teams within the platform. We have a viewer level as well. So for those that come into a team, they can view the data and analysis that occurs within the platform. And there's a contributor level as well that allows someone to upload their data. Additional needs that we heard was around once an analysis or insight was created, sometimes it could be shared within a meeting or report, but then that information gets lost. So we've enabled the platform to save and provide shareable maps that can help build institutional knowledge if information changes, to be able to go back to that map, update it without starting the analysis over again. And again, also, we heard that data analysis could feel out of reach without the help of a data focused role or staff. So, again, we built the platform in mind to make it accessible, certainly to those that do data analysis within their work, but also for programmatic staff as well. And we started to see quite a bit of momentum just since September of last year. We saw nearly over 2,100 new users since that time, nearly a five-fold increase. We were able to engage in the past year with having over 40 feedback sessions and engaging 60 individuals and organizations as well. We ran a key national learning initiative in partnership with the Data for Social Impact team from St. Louis to offer up a webinar series over the past fall. And in fact, when we had our second webinar series right around the beginning of October, where we demoed the platform for the first time, we actually saw a 7-day surge of new users just from that webinar alone. Apologies, I skipped ahead there. And really, a key insight and learning we had from that series was that we had asked those attendees, and they shared with us that 75% were new or light users of mapping analysis tools. And even after we shared information about the platform and did the demo, we saw a strong majority that said that they would apply what they learned immediately. So that was a key insight in that effort that we were heading into the right direction. Now, just before I share with you a quick demo of the tool, we do provide upload guidance to all users. Just to level set there, the tool, the platform itself is stewarded by DataKind. The data is encrypted at rest for any uploaded information. Users own their own data in terms of uploading it. If they delete their account, that data goes with them, for example, and sharing is limited to users and to that team owner role who they decide to add to the team and also share those respective data indicators. So, as a continued reminder, before uploading, it's key to ensure that the analysis question is identified with intention, that any PII, PHI sensitive information is removed before uploading, and minimizing the upload only to what the analysis requires, going back to that intention around the analysis question. Before sharing, confirming rights across organizations, that there's permissions and consent to upload that data. Also, you can upload that data and look at the map before sharing with anyone. So it's always helpful to take a look and check the map just in case there's unintended data to be able to allow that view before sharing across any teams, and also ongoing least privilege. And if there are any issues to share with DataKind, we do have a process that guides toward that resolution. So, without said, I'm going to go ahead and play this.
This example follows a program officer at a small business support organization in New York City. Their team helps small businesses access capital, including SBA loans, and they're trying to answer a simple question. Where are we currently not reaching businesses, and where should we focus next? They start by uploading their own dataset, small businesses they've already supported. Here, they can see that their addresses were validated by our geocoder and can proceed. At this step, they'll be prompted to create a new indicator. Once completed, they can click the Get Started button to go back to the map analysis page and view their pins. On this page, they're going to want to navigate to New York City to best see their data. Next, they layer in a few zip code level indicators to understand where support may be needed most. So we navigate back to select zip code and look at the economic security domain. Here, we're looking at SBA loan activity and a measure of household economic stability. In this case, all three indicators point to higher vulnerability at the lower end of the legend, so where zip codes are lighter in shading. After adding their data set of businesses they work with, they start scanning the map, comparing where their program is active compared to where the indicator suggests additional support is needed. Then they zoom into specific zip codes with that lighter shading, places with lower SBA activity and lower economic stability. They also don't have much of a presence. After visually confirming the dataset they've uploaded, they can now choose to share that with their team members. Click on the share button, they can now share it with all members and their team owners, team contributors, and viewers. Once shared, users can find that indicator back on their own screens when they navigate to the Uploaded Data Indicators drop-down menu. To take this one step further, they bring in a dataset of SBS certified businesses from the NYC Open dataset. Now within those same target areas, they can see actual businesses they would reach out to. This moves the analysis from geography to action, turning areas of opportunity into a pipeline of real businesses to engage. Finally, once they're satisfied with this kind of view, they can zoom back out to a view they would like to store. And they can utilize our new feature to save this map analysis for further reuse. Once they type in a name, they can save the map. This saves both the zone, the center of the map, the indicator selected, and the name, and stores it into your personal profile. Now, if you want to, you can retrieve that map and start your analysis again at a different time from the same state you were at. So in just a few steps, they go from visualizing the activity their program has had, to identifying underserved areas, to building a concrete list of businesses to reach out to, all in a shared visual workspace their team can align around.
Oh, great. So, with that demo in mind, wanted to share some additional use cases that we've seen emerged in those partnerships that we've had as well in terms of how they're thinking about using the platform. So we certainly saw an example with community development financial institutions where they can layer economic indicators with lender data to perhaps identify local investment opportunities in support of small businesses. The example you just saw was around small business support, what outreach could look like to particular areas that they want to provide supportive services to. Within housing, this could be an opportunity to pair public data with hyperlocal housing data within New York, as an example, cost burden, other types of information for collective housing solutions. Even within philanthropy, there's an opportunity for program officers to use the platform to generate insights on how and where to deploy grant funding across communities. Within health, we're also seeing area specific impact on programming, on preterm births, as an example, in certain neighborhoods. And even amongst legal aid organizations, they're looking at ways to identify areas in need of legal services, in particular around housing support to residents, Medicaid, and SNAP benefits. So, if you're interested in getting started, we do have a QR code here. I will note it is not optimized for mobile use, so I'll also make sure to put a link into the chat. If you do have any questions, feel free to reach out to us. Again, this is a preview, so over the next couple of weeks or so, you'll actually see many of these features within production along with a new name. So, thank you for your time. I'm going to turn it over to John next.
So I am going to talk a little bit, and thank you so much for that wonderful review of our community platform. I think there's tons of really great things that could be done in New York City, and great to see a New York City example. I work within our education portfolio at DataKind, and I'm talking about an open source learner information framework and learner infrastructure that I think can be really helpful for solving some of the problems that exist in the world of education. This product is at a much earlier stage in our community platform. I'm going to be sharing some of our early work and sharing some of the research that we've been doing in that space. So right now, one of the things that exists, particularly in post-secondary education, is that for an individual and for institutions as well, data is fragmented, it's controlled by the institution, it's not portable, limiting the agency of a student and their economic mobility. So, for example, many of us have education experiences now that occur in many places. They occur at universities. We do work as we go into the workforce. We're gaining experiences. We may be gaining certifications and all sorts of things that we learn. But the data for us to carry around about ourselves to then apply for work, to prove that we know thing A so that we can learn thing B, is often separated. It's not easy for a person to carry that around with them. So as learners transfer between different learning systems, they don't have a full version of their learning experience, a way to carry that around with them. And so we're working with an open source and an open framework, which is working on open standards to help solve that issue and work in the open community with open data. And the one that we are partnering with is the Learner Information Framework. It's a set of open source tools and data models that work within the existing structures that are out there to translate and bring together learner data in a consistent, governed format that's safe and allows us to have this information in one space so that I could, as a learner, be moving forward with a full understanding of where I'm at so that I can decide what my next step in my learning journey might be. Right now, doing that kind of work of bringing that data together involves a lot of cross-system mapping, data transformations, validations. It's a large implementation, and it doesn't allow for an easy public infrastructure to get this portable learning credential. Like if I really want a thing, it's not easy for me to build that right now. And where that is essentially the problem that we are trying to solve and trying to mitigate. So the question is, could a digital public infrastructure combined with AI tooling reduce access barriers and accelerate adoption? Is there a way to make this happen more quickly for learners so they can move forward, and to think about reducing barriers to getting that done? Especially as we know there's so much availability in the world of AI and tooling is being added to so many things. How could we add AI tooling to help solve this problem and to allow the data sources to come together more easily? So a couple of questions that we set out to answer early on. Can AI support data quality assessments such that we have confidence in the data that's being shared? As soon as trust goes away in the world of data, everything falls apart. And I've taken to saying lately, and I've copied this from other people, but being AI ready means being data ready. So if we have our data in the spot that we can be confident in it, we can understand that the quality is there, we have confidence, then we can be ready to add all sorts of things, machine learning, AI, other kinds of analytics. So a question that we were answering specifically, and the two in the box are the ones I want to give you a quick overview of today. Can AI support mapping from source data systems to target data systems in order to increase record portability? So if you have data in this system over here and you want to move it to this target and you want to bring those two sources together in order for us to make a more full record, can we have AI help with that? And can AI also help with data transformations that need to occur in those spaces? So if we know that there are standard transformations that need to happen in order for that data to be more useful, can AI account for that? So doing this predictive matching across open data sets will allow users to get more of a view of their learning journey. So you can imagine someone in New York City having data in all of these different sources that are available in the open data, in all these different open data files, and wanting to understand, how do I get a view of all of my learning that's occurred, right? It's not only going to be in one system, it's going to be in multiple. And I think having tools like this could be helpful to move that forward. We can go to the next slide. So we decided to test out some different AI methodology, and we did it in 3 different tiers. Tier 1 was traditional text matching tools, of sort of natural language processing work that's been around for a little while, comparing field names and descriptions without having to have something that could understand the context and the meaning. We then worked with some smaller scale AIs, some compact language models that reason about semantics and follow instructions. And then we also use the LLMs as well. You'll probably get one of the ideas here is to try to have some efficiency and potentially lose it using smaller language models instead of having to go for the full-blown, sometimes heavy and expensive large language models. So looked at for 2 different schemas that we're working with. And let's talk about the blue bars here for a moment, which is a schema that exists for a standard set of data that comes from the National Student Clearinghouse. So this is a very common education data set that's used quite a bit, called for the PDP schema. And what we saw is that if you just do embeddings, the score in terms of your accuracy level of those ratings and those embeddings is 0.47. So 1 would be perfect. And that using the small language models and the larger language models, you get a really big leap in terms of being able to do those mappings automatically. So there is a big change there in being able to move that forward. What I think is really important here too is to notice the difference between the small language models and the large language models, the 0.71 and the 0.74 there. We're probably not getting so much more bang for our buck that we would want to go with a large language model. So there's some effort here, and at least as I say early on, there's an indication that we might want to look at, could the efficiency of doing this kind of mapping of data, of the data components, work better with, or work just as well with a small language model. One thing I think is a really important takeaway that anybody working this week in Open Data Week from what we've learned here is that the typical attempts that are out there to work with AI data right now allow for you to do a lot of things really quickly, to make changes and to try experimentation and to be playing around with stuff. But what happens, and what I'm not saying we all are, but I think most of the people on this call probably are very likely to do, is to change lots of things really quickly. And just say, let me try this, and keep optimizing for whatever that outcome is. But as you're doing it, if you're making so many changes in a system that none of us know as deeply as we would like to and will, as we learn more and more about how AI is working behind the scenes, it becomes very difficult to know what of the things that I just changed is actually leading to my improvement. So that has become a really big issue in the world of working with AI modelings with examples like this. So we went back to our kind of traditional scientific thinking and said, well, what do we try to do? Strict variable isolation as much as we can. I'm going to remind us that we're working in a world where we can't control everything, but the more experimental control we can have to do things like when you're comparing prompts, keep the prompts identical. Like, make sure you think about it before you start, so you're not going to be changing the prompts along the way. If you're doing different strategies, Make sure the models that you're using are staying the same. Freeze every parameter that you can. So that's a really important thing. Freeze everything you can so that when something changes, you know what that change is attributed to. And make sure you log everything so that you're keeping all the work that you have so you can follow back with a follow-up analysis when you're done. So what do we find? AI is a genuine leap, a capability leap. Large language models dramatically outperform these traditional NLP methods for bringing this sort of data together. And I know I didn't explain all of the experimentation really deeply, but please reach out to us and I'm happy to provide more information and provide more reporting on all of this. Small AI models work nearly as well as the large AI models, so that's and it's a fraction of the cost. So that's a big suggestion we have from this to look into that. We still want to work in the world of reality where you're going to be processing lots of fields at one. So doing the batch processing outperformed field by field approaches because there was more information for the procedure to use. So actually providing more information made that work turn out better. And then we did find that if you are working with these, particularly in the small language model space, if you provide the information about what transformations need to be done, those simple transformations can be created, or suggestions for those simple transformations can be created by AI. And then I think this is my last slide. What else do we need to think about? This is all human in the loop. DataKind is a very human in the loop and human first organization. So as we've learned, and we do have a bias to this, but the data also said that you're not going to be able to do this without having experts who know it, look through the mappings and understand what's happening here. AI actually changes the tasks that humans are doing. Instead of looking at all fields, humans just have to verify a subset. So how do we go to this spot where we're using these advanced tools to make those of us who are doing the work do better? And false positives are the things that we find. Our emphasis on precision was appropriate. Wrong mappings that look plausible can slip through. That's okay. But if you want to not make false positives, you're better off. You want to switch the thing to make more false negatives. That's okay. We can play around with that if we're setting up the parameters. And I think I'm turning it over to Tali. I'll just say one last thing before I turn it over to Tali. This is, I would say from this work, the idea of having this open framework built on open standards so that you can use open data to begin to understand your user journey with this learner information framework. And we've seen tremendous work. And the other thing I would think about is control as much as you can when you're working with AI, because we don't have as much control as we would like. And I'll turn it over to my wonderful colleague, Tali.
Thank you, John. And thanks also for mentioning data quality, because what I'll be talking to you all about is along the same theme. So really around the use of data, but the responsible use of data, which requires obviously a lot of new ideas, but it also needs some practical tools that strengthen trust in the data itself. And John, you spoke to the importance of that and the importance of having confidence in the data that we're using and then we're sharing. So what I'll be talking to you about is the Data Observation Toolkit. That's actually why we built the Data Observation Toolkit, which is an open source product that automates the management of data quality checks. So DOT is recognized in the Digital Public Goods Registry as a public goods solution that social sector organizations can use to strengthen the reliability of their data. If you look up DOT, we have quite a few blogs about it and information about how DOT's being used out in the world. At the moment, most of those use cases you'll find probably focus a lot on the health sector, where data quality concerns were flagged as not only, I mean, it's serious and a problem in almost any sector, but particularly for DataKind, when we were working with our partners, it was flagged as something that it can be so problematic that, especially for frontline health systems, can really lead to massively unintended consequences, like missing diagnoses, missing morbidities, and actually lead to mortalities. So that's just to say that some of the examples you'll see about how DOT's used is focused on the health sector, but it's actually a completely platform and sector agnostic tool. And it can be adapted to context-specific needs. It can also work on any relational database, and it works across spreadsheets as well. And for those who would be curious to try it, it comes with a Docker build as well. So how does it work? For maximum flexibility, DOT is built using two well-known data integrity libraries called dbt and Great Expectations together. What DOT does is provides a simplified management layer where the data quality tests can be easily configured using a web application. And then the results, when you run it on your data sets, they can be saved for each DOT run, and so that you can actually monitor your data quality trends over time. better than me explaining it would be to see a quick demo, I think. So I'm just going to hand it back to Shayna, please, to share our demo.
Hi there, this is just a quick demo to show you how to run Dot and how the user interface works. So if you're at the Dot Git repo and you're following the instructions, there's a quick start, which allows you to get Dot up and running really quickly with some demo data. If you've run through this, once it's up and running, you should be able to click on this URL and it will open up the Dot user interface running on your machine. So what we can see here is the data is already there from previous scans that Dot has done. This is demo data that comes with the demo. And so for each of these scans, there are run results. So if you click on the view results, you can drill down into, these are tests which are being configured in the demo. For each test, you see the number of rows tested, rows failed, what entity was tested, and the test type. You can further drill down by clicking on any of these. So that will then take you down to a low-level exception table, which shows you the raw data that was tested and the rows which failed this particular test. So that's what Dot looks like. Now to run Dot, as I said before, it comes with a set of runs already. But in the README, there are instructions for how to run Dot. And if you follow those instructions, I'm just going to run through them quickly here. You need to exec into the Docker container, cd into the right directory, and then run this command. Again, these are in the README. It's just to show you that while this is running, this is Dot running through and testing the data that we have in the demo database that comes with the demo. While that's running, we'll come back to it later. You'll see that there are 4 rows here, so just remember that. So how does Dot work in terms of configuration? Well, the first thing you do is you set up projects. So in the demo, we only have one project set, but you could in fact have as many as you want and have different scans, different projects pointing at different databases. Once you have projects, you might find it useful for dashboarding and reporting metrics to set up categories. So these are some demo categories. The data in the demo is airline flights and airports. So we've set up some just basic categories to illustrate how those would work. And then once you've got categories, we have entities. Now these are quite important. Entities define the data that Dot will scan. It won't scan a whole database by default, but what we found from our user feedback is that people want to specify the data that they want to scan, and so you can do that through entities. And an entity is essentially just a view onto the underlying data. So once you've got your entities and your projects and your categories, you're finally ready for some tests. So there's a library of tests ranging from simple blank fields, uniqueness to check whether a column is populated with a set of accepted values, through to statistical tests for outliers. You can also specify custom tests with custom logic, Boolean logic. And finally, you can actually even specify SQL tests where you provide the SQL that will identify the scenario. Those typically tend to get used for tracking signals of interest. So these kind of fields are typical data integrity kind of classifications or test types, but sometimes the custom SQL can be useful. We've seen it, for example, used with community healthcare workers, where maybe a diagnosis was made and the follow-up didn't occur in the required time. So once you've got your tests and everything runs, going back to that run that we had earlier, we can see that this is completed. And now when we go back to run monitoring, what we should see is there's now an extra row. So it's scanned our data and it's produced the test results that we went through earlier. Okay, well, that's a quick tour of Dot. I hope you enjoyed it.
Thanks. And that was my ex-colleague who used to work at DataKine, Matt, taking us through that demo. And that's obviously available for folks to check out on the repo as well. But if you go to the next slide, I just want to share a little bit about how Dot's being used in the real world. At the moment, it's deployed specifically with the Ministry of Health in Uganda. They're working on improving maternal and child health services. This is in collaboration with one of DataKine's longstanding partners, Medic, who have developed also an open source tool called the Community Health Toolkit. They run it every 2 weeks in order to check data quality issues. It's also being used in Lesotho. This is by another one of DataKine's longstanding partners, Riders for Health, who are actually using it to ensure that they actually transport a lot of very sensitive material, medical samples between health facilities and labs. And they actually use it in part to ensure the data quality around their fleet management is maintained. And in, again, another health example, we're using it also with Gavi, that's the vaccine delivery coalition. And so there's a lot of effort there to actually encourage more institutional partners, governments to think about using digital public goods and not necessarily every time looking for closed source proprietary solutions when there might be good solutions, open source solutions available to use. I think there's a lot of rich open data out there. And as we know, and we heard earlier from Shaquille, and NYC has one of the richest open data ecosystems in the world. But like any large data system, quality can vary. And so how do we strengthen that trust in data itself before it's used and channeled into tools that then provide insights and help, like the US Communities Platform, and that data is actually used to generate insights and help decision makers make their important decisions. The aim is really for DOT to help shift from fixing issues after the fact to really being more proactive and continuously monitoring and improving that data reliability. All right, with that, there's the QR code that you can copy here. I'll also paste the link to the GitHub repo in the chat in just a minute. But we'd love for you to explore DOT. So as you can see, there's a lot more that can be done to improve the experience for the user in using DOT. We would love to collaborate and learn more about powerful use cases. We'd love for you to try it out. If you'd like to collaborate with us and think about developing additional meaningful features for DOT, I'd love to hear from you. My email is here. And with that, I will close my presentation and actually hand back to Shaquille.